Hello, everybody. My name is Alexander Finch, and welcome to the first of a few coding lessons that I'm going to be hosting over the next few weeks about, the basics of computer science and scripting and things like that. So we're going to be doing this through game making, and I know a lot of you are very familiar with video games. A lot of you love video games, and I want to ask you, have you ever wondered how these video games are ever created? So, what goes into creating movement and what goes into sort of making something display on the screen. So we're going to go over all of that. We're going to go over input, output, hardware and software, and the basics of how, a computer works. We're going to talk about, if statements, scripts, everything like that. So I think that this sort of mini lesson series is very useful. Um, and we're in coronavirus. It's a very uncertain time for everybody. Um, but I think it can be used very productively. All this extra time that we have, learning something new. And I think computer science is a great opportunity. It's a very versatile thing. It's gaining popularity. Computers are involved in almost everything of everyday life. And I really feel like this can be very useful to you. I'm taking high school classes. I took a computer science course last year. I'm going to take another computer science course next year. And all of this stuff will be very relevant to you in the future. So getting started with game making, we're going to go onto this software called Scratch. And if you don't know what Scratch is, it's basically an online video game engine. So that means it's a platform where you can create your own video games and your own little mini things. Um, and if you haven't checked it out, I advise you just to pause the video and go to scratch.com. You don't have to download anything, I don't think, but you should make an account so you can save all your games. So go to Scratch and make an account, and just check it out. You can test a couple games on there. You can test a couple user-created projects, and that's essentially what we're going to be teaching you how to do right now. So Scratch offers blocked code and a visual scripting system. So instead of typing out every little letter and every little command, you're going to be actually placing blocks of commands. So I'll explain it in depth once we get into the software. But it's a very holistic perspective on coding. And I know it isn't like the cool way of coding. It's not typing out like hundreds of lines of code. But you'll get into that in no time. I certainly had a lot of fun with Scratch. I thought it was a very powerful tool, and you can be very creative with it too. It has limitations, but I think out of those limitations comes creativity. So the more limitations you have, the more you can think out of the box. Um, so yeah, and like I said, this will everything we learn in Scratch. So every command we learn has a direct translation to real code. So once you get into high school, or once you start taking a coding class or a robotics class, you will definitely have use for this knowledge. I promise you. Um, so I'm gonna have also a Q&A every Thursday. So if you have any questions about the previous lesson, you can hop onto that Q&A, and we'll talk about a little bit about how coding works, and we'll have like a mini topic if nobody has questions. But yeah, feel free to contact me too. We'll have my contact information somewhere in the description. Um, but yeah, it's right now. It's just a great time to start learning computer science, and I hope that it'll be something fun for you and something rewarding, and I hope it'll create a good foundation for everybody who is even mildly interested in game development or computer science as a whole. So yeah, thank you so much for watching, and let's get right into it. I want you to ask yourself a simple question. What is a computer, right? And I think that a very, very simple definition for this is a computer is simply a function. And if you're in math and you've went over functions, then this will come pretty easily to you. But essentially, what a function is let's just do a simple example here. So y equals 3x plus 2, right? So this here is a function. This here is a function. And so what is it? What makes it a function, right? And the answer to that is that it has an input, and then there's a function here, and there is an output, right? So in this case, our input is going to be our x, and our output is going to be our y. So the way we sort of deal with this function is we use substitution. So let's say, okay, for the sake of example, let's say x equals 2. X equals 2, right? So then we're basically inputting 2 into our function, right? So you would input 2 and say, okay, 3 times 2, what is that? 6 plus 2, that's 8. Okay? So once you input that into 4x, then you say, okay, 3 times 2 plus 2 equals 8. So then you have y equals 8. Okay, y equals 8 is our output. So this directly corresponds with our output. And, okay, this is basic math, right? How does this have anything to do with a computer? Well, I would argue that a computer essentially is this, right? So, like we established, you have an input and an output, and in the computer you have the same thing, the exact same thing, actually. So let's just divide this up here. In a computer, you have, okay, and if you didn't get this, that's fine, because I'm going to explain it to you right now. I want to ask you, okay, what are the 4 most used keys in video games, right? In Fortnite, for example, what are the 4 keys you use the most? And I would argue, and any gamer would argue, that the 4 most used keys are W, A, S, and D. Okay? And these keys generally in video games define your movement. So, okay, how is your character going to move? Let's say you have a little guy, and let's say this is a 2D game because I can't draw in 3D that quickly. Let's say you have a platform and you want to jump onto this platform and then jump back down to this platform, right? You would use, okay, first you would use D, and then the character would move forward. Then you would use W, and the character would jump, and probably use some sort of physics to determine that, okay, since it was going forward before, it should probably still go a little forward. And then you would use D to walk on the platform. It's a little small. You would use D to walk off the platform, and then you would drop down, okay? So that's sort of a basic program. We see a basic program, and we'll talk about this a little bit later, but that's actually very, very important. So we've established that WASD is our input to our computer, right? So we input WASD from our keyboard into our computer. And now this computer can be anything. It can be your laptop, it can be whatever you're running your program on. It can be anything. It can even be like a microcomputer, whatever you want it to be. Like your phone is a computer, for example. You could be inputting something into your phone. But for the sake, let's just say it's an Apple computer. Simple. you input the WASD into this, and then that creates that movement that we were talking about of your character in your game. So we have a monitor, and this output basically modifies the position of this little guy that you have who's jumping around these little platforms, right? So that WASD is essentially synonymous with our input, and this monitor, this screen, and the changes that are taking place on the screen is synonymous with our output. And what does that leave us with? Well, this function here is synonymous with our computer. So the function in this scenario is stagnant, right? The function essentially is 3x plus 2, right? That's our function. And the computer is a little bit more complicated than that. So a computer is not a stagnant function like this. And one of the reasons is because, okay, you can have like almost infinite methods of input, right? You could have a microphone. A microphone is a source of input. You could have a mouse. Your mouse is a source of input to your computer. It's connected. You could have a webcam or a camera that's on your computer screen. That is essentially a form of input. And you could have as many number of outputs. So you could have a speaker. You could have a little speaker, like playing music. That's essentially a form of output. You can have, okay, we already talked about the screen. You could have a variety of things. You can have your headphones. You can have, there's a huge amount of different things. And it doesn't even have to be, it doesn't have to be one of these preset ones. You can even, like, when you get into hardware design, you can even create your own methods of output or input. And we see a lot of that with things like virtual reality and things like that, right? Where you have very unconventional but also very useful methods of inputting and outputting into our function. And that's very, very important. So let's get into a little bit of why the computer is such a complex function and why it isn't as stagnant as 3x plus 2, right? Give me a break. It's a computer. We can't compare it. I mean, well, we can, but we can't directly compare it to 3x plus 2, right? So we have this idea that we have a computer here. And for the sake of variety, let's say that it's a laptop now. So this is our computer. And we have, keys, maybe a little trackpad here. So we want to ask ourselves, okay, what defines this function? What defines if it's 3x plus 2 or it's something else other than that? Or what makes it able to translate WASD or a sequence of keys, key presses or key releases even, into something that is physically tangible and like real or digitally real, I guess you could say, as a little character moving around the screen, okay? And I think there's a simple solution and there's a complex solution, and I'm going to give you the simple solution. Your computer has an operating system. Okay, it has apps. It has so many different forms of context that it can translate this WASD into a fundamental structure of zeros and ones. So there are millions of these zeros and ones being fed into your computer every second from the different forms of input that you're providing, and sometimes it's just processing. But there are millions of these, zeros and ones here being entered into your computer. This is just like a small random segment that I made up. But this is basically binary. This is binary. And binary is referring to, believe it or not, binary refers to little switches. Okay, and these little switches are just tiny little things made out of silicon that are glued onto this chip, right? And you have millions of these tiny little switches inside your computer. And this is just a basic picture of a light switch that I really didn't draw well, but they're much tinier than light switches, and they're made with tiny little lasers. But you'll get into that when you're in college or you're in high school or something like that. And essentially, when one of these switches, this here programs these switches to either turn on or off. So a 0 will be off and a 1 will be on. So 1, 0. Okay? So a 0 will make it so that one of these switches is on, and a 1 will make it so one of these switches is off. And these switches basically create circuits in your computer. And those circuits, depending on the arrangement of the switches, create different colors and different movements on screen and everything like that. And that's sort of where it gets very complicated, very theoretical, and you talk about like gates and everything like that. But essentially, the way that it can create input into output is through zeros and ones, through this binary code. But we, as coders, do not generally code in zeros and ones. We don't do that. Okay, that's a very slow and kind of, it's just blatantly ineffective way of coding. There are different forms of these primitive, coding languages, such as hexadecimal. And I'm just throwing out these terms here. You don't have to know any of this stuff, but I just want you to get a basic like an idea of it. There's hexadecimal. There's all these different little ways of portraying zeros and ones that are in fact very primitive and very inefficient for coding something like a video game, because a video game is extremely complex. It requires all that basic stuff to be down. So what we have are programming languages. And the most basic programming languages, like we said before, is binary. Okay? It's all this binary stuff. And then once we get a little more complex, we go to hexadecimal and everything. But after that, we go to something like JavaScript or C#. Okay, and this is code where you can more or less understand it, but it's basically a series of, if statements, booleans, variables, commands into the computer that you're directly typing out that translate into that then translate into zeros and ones, and that then translates to the computer. Or no, that then translates into our output, right? So, if we go just one step further than that, we get something called Scratch. And Scratch is what we're going to be working with throughout this little tutorial series. And what Scratch basically is it is just one level above this. So there's binary, Java, and then Scratch is just one level above all of the other things. So Scratch is coded through Java and C# or whatever programming language. It might be HTML. I don't know. Probably not HTML though. And then it goes from whatever script it's running on into these zeros and ones, and then that goes into this. It goes into your screen, or it makes something feasible and physically tangible. So Scratch runs on one of these previous programming languages, and then that translates it back. So why is this useful to you? Why can't we just go directly into coding, and why do we have to learn a little bit about the background of the computer and stuff like that? Well, I think it's very important because we need to understand what the different things we're doing in Scratch actually mean. Okay? So let's take a Boolean, for example. So this is a true or false statement. So a Boolean can be true or false. True or false. And I'll give you a good example of this. Let's continue with the light switch example, actually. Say, okay, so if our light is on, so basically if our light is true, so if our light, let's make this a little bit more easy. We'll say if light on is true, then you do a certain amount of commands. And this, you will directly see this in Scratch. So if our light is on basically, then tell the computer to do a certain number of things that we can define later on. And now what this is essentially is it is changing our Boolean, or it is changing our binary code that is being processed in our computer. So out of all those little zeros and ones, there's millions of them running through your computer at each second, right? This light on statement is gonna check. It's gonna read it's gonna read this series of Boolean numbers, right? And then it's gonna check, okay, if there is a certain sequence of binary numbers, if that is present, then it will do a certain thing. And now all of these, this is all pretty, when you boil it down to binary, it's way more complicated, way more complex than that. But this is just a basic sort of example to sort of boost your understanding of it. So I want you to keep in mind that a computer is essentially a set of functions that is defined by these zeros and ones here. Okay? That's all I want you to take away from this. And I want you to start noticing that those, zeros and ones, and how, all of this stuff can be changed and scanned and stuff like that in Scratch when we start doing our next lesson. So that should be all for today. And if you have any questions about this lesson, I know it was a lot to take in. You don't have to know directly, like you don't have to have a background on, Booleans, or you don't have to have a background on, all this math stuff. But if there's any conceptual things that you don't have that solid of an understanding on, you can contact me, or you can attend the live Q&A session on Thursday that we're going to have. And we'll go from there, and we'll start creating our Scratch game. And you'll see how, Scratch filters back through all of this and gets translated into a movement on screen, or a change in the look of your character, or skin, or however you want to call it. And that will sort of give you the basics, the fundamentals of computer science. So that's pretty much it for this video. Please remember to check out Scratch if you haven't already. And I hope to see you guys soon. Thank you for watching.